Okay, 6.1 in pre-calculus, we're going to talk about the law of sines. 6.1 is law of sines, 6.2 is law of cosines. They can be used to solve triangles. Up until now, you've only been able to use your trig on right triangles because you had hypotenuse over adjacent or an opposite over adjacent. It had to be a right triangle. Law of sines, law of cosines, now we're going to be doing them for any triangle. The lowercase letters are sides, the uppercase letters are angles. Please notice how side A is opposite angle A, and say side B is opposite side B is opposite angle B, and so forth. That's law of sines. That's 6.1. It's probably a little easier to remember than 6.2, which is going to be law of cosines. So 6.1 is law of sines, that's on the left. 6.2 is law of cosines, that's on the right. I recommend when we do these that you're going to use law of cosines once, law of cosines once, and then after that you can probably shift back to law of sines. Law of sines is easier to remember, it's probably a little easier to use, it's just proportions. Law of cosines is a formula, that once you get it down it's not too bad. I wanted to introduce 6.2 early so you have a little more time to look at it and think about it. But no, we're going to do them one section at a time. We're going to do 6.1 and then 6.2. But they are related. They're both used to solve these triangles. 6.1 also gives us area of oblique triangles. Apparently oblique triangles are any triangle that does not contain a right angle. So pretty much all of these that we're going to be dealing with will be oblique triangles. And there's an area formula. If it's a sine of A, 1/2 the other two sides. Sine of B, 1/2 the other two sides. Sine C times 1/2 the other two sides. So those are just formulas for areas. Most of these problems are going to involve solving triangles. To solve a triangle means you have to give all three sides and all three angles. So they're going to give you 3 pieces of the 6 and you need to find the other 3. Now, if you may notice, do they give you both C's, the angle and the side? If they ever give you both A's, both B's, or both C's, you can use law of sines. So I'm going to use the law of sines, not to mention it's 6.1, it's the only thing we know so far. So, law of sines. Why am I going to use C over sine C? Because I'm given both of them. That's why. And now do you want to do B over sine B? No, because I don't know either of the B's. But I might use A over sine of A, right? So let's go ahead and fill some stuff in. Okay, do I know angle C? 63 degrees. Do I know angle A? 46 degrees. Do I know side A? No, so I leave it as a variable. Do I know side C? Yes, it's 56. So I'm going to solve this for A. 2 fractions equal to each other, I can cross multiply. A times the sine of 63 degrees is equal to 56 times the sine of 46 degrees. Opposite of multiplying is to divide, so you get 56 sine of 46 degrees. All that divided by the sine of 63 degrees. Here's where we break out the calculator and it becomes an approximation. So I made sure my calculator was in degree mode. I punched it in. It says to round it to the nearest tenth. So that 1 is not going to round the 2 up. So I believe this, side A is 45.2. So the ones I'm finding I'll put in yellow, 45.2. Now I usually do the angles because you know the total degrees in a triangle is 180. So you currently have 46 degrees and 63 degrees. I think they add together to give me 109. Does that sound right? And if I was to subtract 109 from the total degrees in a triangle, I believe it would leave me with 71 degrees for angle B. Now I need to use something to find side B. Now, I hope you're going to pay attention here because I'm going to use C over sine C as opposed to A over sine A. Can anybody tell me why? Well, the reason I would do it is C is both given, aren't they? Whereas this is an approximation. So I'd rather use the one that's exact. So that's why I'm using C over sine C and B over sine B. So I'm going to fill in. What is side C? 56. What is angle C? 63 degrees. Side B is what I'm looking for, and the angle B is 71 degrees. Again, two fractions equal to each other, you could cross multiply. It's called a proportion. B times the sine of 63 degrees equals 56 times the sine of 71 degrees. Again, the opposite of multiplying is to divide. So I'm going to divide both sides by the sine of 63 degrees. And this should tell me what B is approximately. Punching it into my calculator in degree mode, I get 59.426. And if I was to round that to the nearest tenth, the 2 is not going to round it up. So it should stay as 59.4. Now I urge everybody to do a check. What's the biggest angle? Is it opposite of the biggest side? What's the smallest angle? Is it opposite the smallest side? Once I've done all these checks, I'm pretty convinced these are the correct answers. Okay, they give us angle C to be 96 degrees, angle A to be 44 degrees, which I put over here, and 42 degrees that is, and I need to find all the other missing parts. Opposite angle C is side C, opposite angle A is side A, and so forth. The reason I'm going to use C over sine C is both of them are given. So I'm going to use C over sine C. Now it doesn't matter, I could use A over sine A or B over sine B. The problem is I don't know the angle B. It's not that it's hard to find because 42 degrees plus 96 degrees is 138 degrees. If you subtract 138 degrees from 180 degrees, I think that leaves you 42 degrees. So apparently this is an isosceles triangle. Because if you have two base angles being the same, the sides opposite them should be equal because it's isosceles. But we'll find that out now. So I want C over sine C, and I want A over sine A. So what is side C? 12. What is angle C? 96 degrees. How about side A? I don't know side A, so I'm going to leave it. How about angle A? 42 degrees. Again, you can cross multiply. A times the sine of 96 degrees is equal to 12 times the sine of 42 degrees. When you divide, you get 12 sine of 42 degrees divided by the sine of 96 degrees, and I'll punch that into my calculator. If I punch this into my calculator, I get 8.07. However, rounding the sides to the 10th, that 7 is going to round it up, and we're going to call it 8.1. So this is side A is 8.1. If you notice that this is isosceles, two base angles are congruent, means the sides opposite them are congruent. It might tell you that side B is 8.1 also. So there's question 1. We solved the triangle. Again, I would ask you to check, is the largest side opposite the largest angle? And is the smallest side opposite the smallest angle? And again, if that's the case, you probably did it right. Yeah, if you want to be 100% correct, the ones we found here and here are approximations. You can indicate approximations with a squiggly equal sign. Like it's an approximately equal to is what it is. When you get to question 2, I always say that when you're given two of the same, like C and C, that's when you use law of sines. We're in law of sines, but I don't have both A's, I don't have both B's, and I don't have both C's. However, I think I could easily find angle A, in which case I could use A over sine A equals B over sine B, or C over sine C. Anyway, 54 degrees and 82 degrees add together to give me 136 degrees. 136 subtracted from 180 degrees leaves me, is that 44 degrees, I think? 44 degrees. Is that the smallest angle listed here? That means that 16 is better be the smallest side, because the smallest side should be opposite the smallest angle. So we're going to do A over sine A equals B over sine B, if that's okay. So what is side A? 16. Angle A, 44 degrees. Side B is 54 degrees, and angle B is 54 degrees. What's side B? I don't know, so that's what I'm trying to find. Again, we can cross multiply, so that gives me B times the sine of 44 degrees equals 16 times the sine of 54 degrees. Again, we're going to divide sine of 54 degrees divided by the sine of 44 degrees. At this point, I use my calculator, it becomes an approximation. So let's clear all this out, do 16 times sine 54, take that number, divide by the sine of 44, and it gives me 18.634. 18.634. Is that going to round up, or does it stay 18.3 or 18.6? I think B stays 18.6, right? 18.6. So now I'm going to use another one and do A over sine A, but this time I'm going to use C over sine C. Some people like this section because it's really pretty rote. You're simply following a formula. So what is angle, or side A is 16. What was angle A? 44 degrees. Side C I don't know, but angle C is 82. Cross multiplying C times the sine of 44 degrees equals 16. Let me make a little room here. Okay, let's do it again. C, let me do it down here. C times the sine of 44 degrees equals 16 times the sine of 82 degrees. So I'd have to divide 16 sine of 82. It would have to be divided by the sine of 44 degrees, making C approximately 16 times sine 82 divide by sine 44, 22.8, 22.808 to the nearest tenth, that would be 22.8. Now again, check it real fast. Is the biggest side opposite the biggest angle? And is the smallest side opposite the smallest angle? So these are the right answers for number 3. Okay, the problems in the group 13 to 15 are basically the same thing. They just don't give you a picture like they did in the first couple. I am going to use A over sine A because both A and side and angle are given. So I'm going to do A over sine of angle A equal B over the sine of angle B. Yes. Okay, what is 13 then? Let me fix it up. Sorry about that. I wrote down the problem from number 9, but here's the correct 13. So do they give me both C's in this case? That tells me to use law of sines, and I'm going to use C over the sine of C. And I might use A over the sine of A because I know something about it. So let's fill into this formula. Side C is 200. Angle C is 35 degrees. Side A I do not know, but angle A is 115 degrees. When I cross multiply, I get A times the sine of 35 degrees equaling 200 times the sine of 115 degrees. Again, we're going to divide to get A by itself. So I need to divide by the sine of 35. Punching it in my calculator. 200 times sine of 115 degrees. Take that number, divide by the sine of 35 degrees. And I get 316.019. 316.019. I don't think that's going to round, so I'm going to call it 316.0. 316.0. It says to round to the tenth, so I'm going to put that because that would round it to the tenth. Can I find angle B? Yes, 115 plus 35 degrees gives me what, 150, I think, degrees? If I subtract that from the total degrees in a triangle, it should leave me with 30 degrees. So I believe angle B is 30 degrees. So now I'm still going to use C over sine C because both C's are given. But this time I'm going to do B over sine of B. And we'll fill these values in. Okay, what is side C? 200. Angle C, 35 degrees. Side B I'm looking for, but how about angle B? 30 degrees. Again, cross multiplying gives me B times the sine of 35 equals 200 times the sine of 30. And so I would have to divide 200 sine of 30. Opposite of multiplying is to divide, so I divide by the sine of 35 degrees. Again, once you punch it in your calculator, it's becoming an approximation. 200 times the sine of 30, and divide that by the sine of 35, gives me 174.3446. 174.3446. Rounding this to the nearest tenth, that 4 will not round it up, so I'll call it 174.3. Smallest angle is 30, right? Is that the smallest side? Biggest angle is A. Is that opposite the biggest side? So we've got 13 done correctly. For all the previous problems, you're given two angles. You're given two angles in 13, you're given two angles in 3, you're given two angles in 1. You're given two angles in the example. But now they're not giving you two angles. You're going to have to still use law of sines. Am I given both A's? Excuse me. Since I'm given both A's, I'm going to use A over sine of A. It really doesn't matter, but I think I'll use B over sine of B because I know something about B, don't I? So let's do A over sine A and fill in. Okay, what is side A? 20. What is angle A? 40 degrees. Side B is 15, but I don't know what? Angle B. So I have to have the angle B as my variable. So I cross multiply. I get 20 times the sine of angle B equals 15 times the sine of 40 degrees. Sine of angle B then is going to equal 15 sine of 40, and then I'd have to have that divided by 20. Do you remember how to get rid of a sine? You take the arc sine. So if I do the arc sine of one side, I would have to do the arc sine of the other. So I'm going to do the arc sine of 15 sine of 40 degrees divided by 20. Okay, so this gives me the arc sine. When I do that, I'm going to end up with the arc sine of hopefully something between -1 and 1. 0.482, I believe this becomes. 48209. If you more digits you put, the more accurate you'll be. And then as long as I'm in degree mode, if I do arc sine of that previous number, it should give me, in this case, 28.822. 28.822 to the nearest tenth. They want degrees to the nearest angle, so I'm probably going to call that 29. They want sides to the nearest tenth, so I'm going to call that 29 degrees, and that's angle B. So let me put what I found in a different color, so I'll do this blue, 29 degrees. Doesn't show up that well, I'll use yellow. 29 degrees. Now if I add 40 and 29, I get 69. And if I subtract that from my total degrees in a triangle, that should leave me with what? 111, is that right? 111 degrees. Now you may notice it's not really 111 degrees because it's not really 29, it's 28.8 something. So that's going to be a little off. We're going to have a little bit of rounding error, but we just want to minimize it by using more digits, basically. And continue to use A over sine A. Why am I using A over sine A? Because both of those are given. So let's fill this in. Side A is 20. Angle A is 40. Side C, I don't know. Angle C is about 111. Again, it's not exact, so we've got a little bit of approximate rounding error. C times the sine of 40 degrees is equal to 20 times the sine of 111 degrees. So C is going to equal what? You're going to have to divide by the sine of 40. So 20 sine of 111 divided by the sine of 40 should give me sine C approximately. 20 times sine of 111. I want that number divided by the sine of 40. My calculator says it's 29.04, which if you round that to the 10th, they're going to call that 29 or 29.0. Now let's do our check. What's the biggest angle? Is it opposite the biggest side? Smallest angle, is it opposite the smallest side? So it looks like we have this correct. Good luck with the assignment.